Example 11. What is the pH when 25.0 milliliter 0.100 molarity sodium hydroxide is added to 15.0 milliliter 0.200 molarity hydrochloric acid solution? The temperature is 25.0 degrees Celsius. This is the summary of this problem. Let's look at the flowchart. The first question we need to answer to use the flowchart is how many solutes in the solution? In the solution, we have sodium hydroxide and hydrochloric acid. Apparently, there are 2 solutes in the solution. The next question we need to answer is, are the solutes react with each other? Sodium hydroxide is a strong base. Hydrochloric acid is a strong acid. Acid will react with base. According to the instruction of the flowchart, we need to use stoichiometry to figure out what chemicals will be in the solution after the reaction. And we also need to calculate how much of each chemical in the solution after the reaction. Then we will go back to the beginning of the chart. Let's do the stoichiometry first. For stoichiometry calculations, we need a balanced chemical equation. And for stoichiometry, it is a very good idea to organize the information of each chemical below the corresponding chemical under the chemical equation. We are provided the information of both reactants. This is the limiting reactant type of calculation. Before the reaction, we have 0.0030 moles of hydrochloric acid. Before the reaction, we have 0.0025 moles of sodium hydroxide. From the balanced chemical equation, hydrochloric acid will react with sodium hydroxide according to 1:1 moles ratio. Therefore, sodium hydroxide is the limiting reactant because it has less amount than hydrochloric acid. After the reaction, we will have non-limiting reactant left. We should have excess reactant left. Let's calculate how much the excess reactant, which is hydrochloric acid, left after the reaction. After the reaction, we should produce some sodium chloride. Therefore, we should have 1 and 2 solutes after the reaction. Let's go back to the flowchart. We should follow this branch because we have 2 solutes. But one thing I should point out, which I left out in the flowchart, is sodium chloride is a salt of the reaction between a strong acid and a strong base. It will not have any effect to the pH of the final solution, which I should add it here because any of these 3 doesn't apply here. Make sure you make corrections on your flowchart. So, in this case, if we don't count sodium chloride, we will have only 1 solute in the solution. HCl is a strong acid, so this will give us an answer. And we have the moles, and we should have the total volume of the solution after the reaction. The total volume of the solution is equal to the sum of these 2 volumes. Next, we can use the definition of pH to calculate the pH of the solution by using the equilibrium concentration of the hydronium ion. We're done. Can you follow my example to work out this problem by yourself?